Let us look at the application of linear equation. There are a few steps we need to consider. The first is we have to read whatever information we have been given, that is the algebraic formation we have been given. Then we represent the quantities to be found by letters, mostly that is variables. Then we form an equation which conforms to the given information. Let us see how we will solve common example relating to this. Good. So we see the example. It reads, when a certain number is subtracted from 10 and the result is multiplied by 2, the final result is 4. Find the number. When a certain number, so solution. Let me use this as solution. Okay, we let the number be say as let the number be equals to x, so x is the number. So from the information, when a certain number is subtracted from 10, so we are subtracting x from 10. Therefore, from the first information given, we have 10 minus x. 10 minus x is a result. And the result is multiplied by 2. So when I take x from 10 and I multiply the whole of this by 2, the result is equals to 4. We have to find the number. So what is the number? That when I subtract it from 10 and I multiply the results by 2, I'm going to get 4. So in this case, what I'm going to get is I'm going to let these 2, don't need to open the bracket. I just have to divide through by 2. So I divide here by 2 and I divide here by 2. Now 2 is gone. 2 cancels 4, 2. So I now have 10 minus x is equals to 2. I want x, so I'll let x cross the equal sign. So when x crosses the equal sign, I'm going to get 10 to be equals to 2 plus x. It's x I want, so I'll let these 2 come back. So 2 coming back, I'm going to get 10 minus 2 equals to x. Then finally, what are we going to get? We are going to get 10 minus 2 is going to give me 8. So we are going to get x to be equals to 8. So your final answer is such that x equals to 8. Okay, so let's see this question also. Now it said if 1/3 of a number is added to 1/5 of the same number, the result is 8. Find the number. So in solution, we can say let the number be say x. Let number be equals to x. So if the number is equals to x, then what will be the next thing? Then we said 1/3 of x. 1/3 of a number is added to 1/5, 1/5 of that same number is equals to 8. So we can easily look at it. So we assume that this one is also over 1. So as I said in the morning, when you have a relation like this, the best thing to do is that if the denominators are the same, you can write this as a single fraction. So what I do is that I multiply the top and the down by the denominator here, and I'll multiply top and down by the denominator here. Okay, so doing that, I'm going to get, and again, this x is multiplying the numerator. Likewise, this is also multiplying the numerator. So I'm going to get 5x over 15. That means 5 multiplying 1 and multiplying 3 plus what we get, 3x over 15 equals to 8 over 1. Yeah, so because the denominators are now the same, we can just put them together. So we got 8x over 15 equals to 8 over 1 is the same thing. So at this point we can apply cross multiplication. So 1 has to go here. I'm going to get 8x, then 8 times 15. Good. The best thing to do is to multiply this, but because I want x, I have to divide through by 8. 8 here and 8 here. 8 will cancel 8, and x here equals to 15. Okay, so let's look at this example too. We say Mark is 30 years old. Suppose 30 years older. Okay, 30 years old, period. Full stop here. Yao is half as old as Mark. What do you make here? Now Mark is 30 years old. Yao is half as old as Mark. So it means that if Mark is 30 years old, then half Mark's age is Yao's age. And Paul is 10 years older than Yao. So solution: Mark's age (30 years). Yao's age is equals to half the age of Mark, half of 30, which is going to give me 15 years. And we got Paul's age is, Paul is 10 years older, means is Mark's Yao's age plus 10. So Paul's age is going to be 15, which is Yao's age, plus 10, which is going to give me 25 years. 25 years. So that is how old Paul is. Okay. See, the sum of ages of Yao and Kweku is 30 years. Yao is 4 years older than Kweku. How old is Kweku? In this case, it will be very difficult for you to just be able to express it. But first thing you have to know is that you have to choose the least age. When you add Yao's age, so Yao and Kweku. So if Yao is Y, Yao is Y, Yao is equals to Y, and Kweku equals to K. We say when we sum their ages, that means Y Y plus K must be equals to 30 years. 30 years. But the law says that Yao is 4 years older than Kweku. So it means that if Kweku is K, Yao. Kweku is K, Yao will be equals to K plus 4 because Yao is 4 years older than Kweku. So from this, you can clearly see that we got a simple dimension. So we got K, which is Kweku, plus K plus 4, which is Yao, equals to 30. Let me bring it a little bit back so that I can get enough space. Okay. So K, who is Kweku, plus K plus 4, who is Yao, equals to 30, indicating that whatever Kweku is, when you add 4 to Kweku's age, is equals to Yao. So the K plus 4 is equals to Yao. Good. So K plus K will give me 2K, that is Kweku's age, equals to 30 minus 4. So 2K equals to 26. Divide here by 2, divide here by 2. So K, Kweku, equals to 13 years. So at this point, Kweku's age is what? 13 years. In a school of 940 pupils, the number of girls exceeds the number of boys by 150. How many girls are there in the school? How many girls are there in the school? So a question like this, one thing you are supposed to know is this: the girls are a certain number more than the number of boys. So the base number becomes that of the boys. So you have to use the boys' number as a yardstick. So if boys is equals to, let me say, let me use X, then girls must be equals to S plus 150. We say so because we say the number of girls exceed. That means they are more than. Exceeding means they are more than. Good. They exceed the number of boys by 150. So if the boys are X, the girls must be X plus 150. And the total number, therefore, we have here the total number X plus 150 equals to, let me bring it more back, small space. Got X plus another X plus 150 equals to 940 equals to 940. Good. So what it implies is the S and S are common, so we can add them. 2X equals to 940 okay, 940 minus 150. Okay, so a matter of subtraction. So we got 2X here equals to 0 from 0 give me 0. 5 from 4 impossible, so I borrow 1, making it 14. So if I borrow 4, making 14, 5 from 14, what will I be left with? It will be left with 9. This one is left with 8, so I take 1 from it. It will be left with 7. So it means that 790, that is 2 times S. So in this case, you divide here by 2, divide here by 2. Okay, 2 is gone. Now we've got x here to be equals to. You are going to divide, and it is always through this manner. So as we have been trying in a previous dimension, 2 will go to 7. How many times? It will go there 3 times with a remainder of 1, bringing it to 19. And 9 becomes 19. 2 will go to 19. 2 go there 18. That is 9 times. 9 times 2 will give me what? 18. So there's still a remainder of 1. So we bring it here. So you're going to get 5. So x equals to 395. Then 395 equals to boys. But girls equals to 395 plus 150. So girls population in the school is going to be 5, then 4 with a remainder of 1, 5. Good. So the girls population is 545 in that regard. Okay, so get 545 to be the population of the girls. Good. Okay, so we see the question read, Kofi is n years old now. How old was he 5 years ago? How old will he be 10 years from now? If his age in 10 years time will be 4 times his age 5 years ago, how old is he now? So we are going to look at a solution. Okay, we say Kofi is n years old. So Kofi's age is equals to n years. That is the current age. Good. Now we go on. How old was he 5 years ago? That means 5 years back. So his current age is n. So 5 years back means n minus 5. So we're just answering the question. So because it's 5 years back, we're going to get n minus 5 years. 5 years ago. Okay. Then it goes on to say how old will he be 10 years from now? So 10 years from now means that additional 10 years. So in 10 years from now, Kofi will be n plus 10 years from now. Good. Then we can, if his age in 10 years time would be 4, well, the term well means equals to. So if his age in 10 years time, which is, we know this is his age in 10 years time, well means it is equals to 4 times its age in 5 years. So it means that looking at it here, his age in 10 years time, which is n plus 10, is equals to 4 times his age in 5 years time, n minus 5. Good. We are supposed to find his age now. That means we are supposed to find the value of n. So we got n plus 10 now equals to, open the bracket. So 4 times n will give me 4n, then minus 5, minus 20. You are opening the bracket. The 4 will multiply 5, minus 20. Okay, what we do now is we group like terms. So grouping like terms, we let numbers be at one side and let variables be at one side. So we're going to get 10, this 20 crossing will become positive, plus 20, 10 plus 20 is equals to 4n minus n. So 10 plus 20 will give me 30 equals to 3n. Divide through by 3. So how old is Kofi now? Kofi's age now is equals to 3 cancel 3, 3 goes here 10. So Kofi is 10 years now. Kofi is 10 years now. So Kofi's current age is 10 years now. Okay, now let's look at this question also. So the average age of a family of 8 is 30 years. The average age of 6 children in the family is 19 years. If the mother is 4 years younger than the father, calculate the age of the father. Wow. So let's see how we solve this. So solution. When talk of average, is the total sum of ages over the total number of outcome. So the total sum of ages, we don't know the total sum of ages. So it's the sum of ages. In this case, we let total sum of ages, the term summation, sum of ages over the total number of occurrence. How many are occurring? 8. So 8 is equals to 30 years. So what is the total sum of ages in the family? So we're going to get sum of ages in the family to be equals to 30 times 8. So sum of ages in the family is going to give us 30 times 8 is going to give me 240. That is the total sum of ages, so 240 years. When you add all the children, including their parents, you are going to get 240 ages. Now the question goes on further to explain that there are 6 children. 6 children. So if the average age of the 6 children is 19, so in this case, the step 2, we're just going to look at sum of ages of children. Let me make children C over the total number of children. We have got how many? 9 children is equals to 19. If that is the case, then the total number of ages of the children is going to be equals to 19 times 9. 19 times 9 is 100. 9 times 10 is 90. 9 times 9 is 81. So if it is 81 plus 90, I'm going to get the sum of children ages is going to give me 171 years. Okay, good. The question is not complete. Now we know the total sum of ages of the children and the total sum of ages of all, including their parents. These are for the 6 children. The children are 6, not 9. Sorry. So there's an error here. Let me rectify it before it becomes. There's an error. Lest I don't go further. Good. The children are 6, not 9. The children are 6. So what it means is that the sum of ages of the children is going to be 19 times 6. We say 6 children. That is 6 children have the average age of this. So the sum of ages of all the children is going to be given as 19, that is 60 plus 54. 60 plus 54, which is going to be 114. So 114 years is the total sum of ages for only the kids. Good. Okay, so at this point we see we've got two different sums. This sum contains the children and the parents. So we find the difference of the children, the parents, the sum of the parents' age. So sum of the parents, let me make this P, plus sum of the children's age is equals to 240. Means that when we sum of XC and P for parents, C for children. So if you put this and this together, we are going to get 240. Good. So at this point, we don't know the sum of the parents' age, but we know the sum of the children's age to be 114, to be equals to 240. So in conclusion, we say sum of the parents' age. Sum of the parents' age the parents' age is 2 minus 114. So I'll take I borrow 0, 10, 4, 6. Okay, so here is left with 3, 2. So 1, 2, 6 becomes sum of the ages of the parents. Good. Comes sum of ages of the parent. So let us get that aspect. Let me bring it down so that it can be seen clear. So we just find the difference, as you can clearly see. Sum of the parents' age is going to be 240 minus 114, and the striking gives me this. Good. Now there's further information which goes on to say if the mother is 4 years younger than the father, calculate the age of the father. So the information is more clear. Now the sum of their ages is 1, 2, 6, and we said the mother's age, the mother is 4 years younger than the father. It means that if the mother is equals to X, father will be equals to X plus 4. If the mother, which is younger, you should always bear that one in mind. The father's age, so the mother will be X years, the father will be X plus 4 years. And we say sum of their ages, that is X plus 4 is equals to 126. That is the total sum of the ages of the parents. So we got 2x here to be equals to 126 minus 4. Okay, so 2x equals to taking 4 from this, I'll be left with 122. Okay, so dividing through by 2, I'm going a little bit up, and dividing here by 2, 2 cancels 2. I'm left with x here 161. X equals 1, that is 61. Okay, so 61 times 2, so give me 61 here. So if the mother is 61 years, the father's age is equals to x plus 4, which is equals to 61 plus 4, 65 years. So the father is 65 years of age. The father is 65 years of age. Good. Two consecutive odd numbers are such that 7 times the smaller subtracted from 9 times the bigger gives 144. Find the numbers. We are finding the numbers. So solution. Okay. To work out for consecutive odd numbers, if they say the first number is x, the second number will be x plus 2 in that order, in even dimension. So if the first number is 1, 1 plus 2 will give me 3. So x plus 2 plus another 2 is going to give me another odd number. Now the information that we have been given says that from what we have, 7 times the smaller subtracted from 9 times the bigger. So they are just 2. So we have got x and just x. So when you have consecutive odd numbers, just follow it in this domain. If the first is x, the second one must be x plus 2. Is that okay? So you add 2 to consecutive odd numbers to repeat odd numbers. If you add 1 to odd number, you are going to get an even number. So don't say x plus 1, but x plus 2 is what you have to. So from the information, 9 times the bigger, x plus 2. Let me bring it back. So 9 times the bigger, x plus 2 minus 7 times the smaller, x, give 144. So we have to get the numbers. Okay, so 9 times x will give me 9x, then 9 times 2 will give me 18, minus 7x equals to 144. Okay, let's check n group like terms. Now I've got 9x minus 7x equals to 144 minus 18. Okay, so I've left it 2x here to be equals to, take 18 from this. If I take 14, I'll be left with 130. So I'm left with 126. So 126. Yes, I'm left with 126. So I divide 126 by 2 and by 2 here. So x here equals to, then 2 goes to 126. If 2 go to 12, 6. 2 go to 6, 3. Means I'm going to get s to be 63. Therefore, x equals to 63. That is the smallest. S plus 2 equals to 63 plus 2, which is 65. So the consecutive numbers are therefore being given as going up, 6, 3, and 6, 5. So these are the consecutive numbers. Good. We'll halt the application of the algebra at this end, since some will also be repeated at the inequality. So until then, let's meet for the next lesson tomorrow for the inequalities. Yeah.